In this video, I follow up on the first tutorial where I created a simple window. In doing so, unfortunately, we created a small problem, as we will soon see in the activity monitor. We are burning up a lot of CPU time. Basically, everything the CPU has to offer is used by our program. The reason for that is our main loop, which is just running as fast as it can without any interruption. To fix this, we want to run through the main loop only once and then wait for a signal from the display, to run through it again until we get another signal from the display. In our case, we're going to use an endIsCondition object, which allows us to do exactly that. Wait on the signal and execute the main loop once, then wait again. The next question is, how do we even know when to signal our condition? And this can be done, or in our case, will be done by a so-called display_link object, which is connected to the display and will call us in a function, callback function, whenever the display refreshes to a new frame. Setting up a display link involves a couple of steps. First, we need to create the display link, and then we need to configure the output callback, which is going to be a free function we are calling display callback. The last parameter in this set output callback function is just passing our own window so that we have access to the signal we want to trigger. Finally, we need to implement the not yet existing display callback function. In order to be recognized as a proper display callback function, we need to pass in the correct parameters described in Apple's documentation. So here we can see which exact parameters we need to pass in. The only parameter we are going to actually use is the last one, the context. And this happens to be the pointer to the window object we passed in when we did set up the display link output callback. Now we cast the context back to a main window object, and in the next step, use the window to access the signal and signal the signal so that in our main loop we will run through the whole loop once until we wait again. Trying to build the project reveals a small problem. Obviously, the display link API is unknown to our compile part, more specifically to the linker, and that's simply because we have not yet included the core video framework, which includes the display link. Building and running the program now should validate that we are not burning up the CPU anymore, since we now run with the refresh rate of the monitor. Thanks for watching.